Dear students, in today's video we are going to deduce Coulomb's law from Gauss law. We know that in electrostatic chapter these two laws are very important from examination point of view. First of all, we will discuss what is the definition of both these laws. Gauss law is used to calculate phi E. Phi E represents the total electric flux over a closed surface S. Suppose this is any closed surface. Q inside is the total charge present inside this surface. Then the electric flux is given by surface integral of dot product of the electric field and the area vector. Here ds represents the area vector. Then phi E is equal to the total charge inside the surface divided by epsilon naught. Right? So the electric flux over a closed surface is, when it is placed in the vacuum, is 1 upon epsilon naught times the total charge contained inside that surface. Then the second law, that is the very first law of electrostatic, is the Coulomb's law. Coulomb's law is used to calculate the force between the charges. We have 2 point charges. One charge is Q1, another is Q2. They are separated by a distance r. R is the distance between these two charges. Then force is directly proportional to product of the charges and it is inversely proportional to the square of the distance between the charges. Force is given by this expression, right, where 1 upon 4 pi epsilon naught is the constant of proportionality. This epsilon naught represents the absolute permittivity of the free space. Now, to deduce the Coulomb's law from Gauss law, we consider a positive charge Q placed at the center of the sphere. This O represents the center of the sphere, plus Q charge is placed over here. The electric field produced from the plus Q charge will radiate in the outward direction. So due to this plus Q charge, E electric field is produced and it is outward in direction. R cap represents the direction of the electric field. R cap is the unit vector. R is the radius of the sphere, right? We have chosen the observation point P. So around P, we have chosen a small area element, that is ds. Then in this area element ds, the area vector will be product of ds and a unit vector which is drawn normal to the ds. We can clearly see from the figure that r cap and n cap are the unit vectors and they are parallel to each other. So r cap dot n cap will be equal to 1. Then we write down the Gauss theorem. According to Gauss theorem, the total electric flux is given as Q divided by epsilon naught. E vector dot ds vector is actually A vector dot B vector, which can be written as AB cos of theta, right? This A and B represents the magnitude of A vector and magnitude of B vector. So it is E ds cos theta. And theta is the angle between electric field and the normal, right? And we see that this theta comes out to be 0, right? So E ds cos theta, when theta is 0, cos 0 is 1, so it can be written as E ds. E is the electric field, which is constant. It can be taken out of the integration. So the integral is left over the ds only, right? So this is the small area ds. If you want to integrate for the entire sphere, the whole area is to be considered, right? And we know that the surface area of the sphere is 4 pi r square, right? So this integration has value 4 pi r square, right? And r is the radius. We put 4 pi r square here. Then we shift this 4 pi to the another side and we have this expression for the electric field, right? So this is the electric field intensity at point P. The P is the point of observation lying at the boundary of the sphere, right? So we have calculated the electric field at point P. Suppose we bring any another positive charge which is plus Q naught, plus Q0 or plus Q naught, whatever you want to say. at this point P, then the force which this particular charge Q0 will experience can be given by the equation that F is equal to Q into E. This thing we have done in the first chapter. F is equal to QE. Substitute the value of E from here, right? And little bit simplification, we get force is equal to 1 upon 4 pi epsilon naught Q0 divided by R square, right? So this is the definition of Coulomb's law. So we can deduce Coulomb's law from Gauss law. Thank you for watching. Kindly like, share and subscribe the channel. Thank you.